Hi, it's Alpha. I want to show you what I've been working on for some time, and that's a player refactoring in Liblast. So before, everything was hard-coded in player.gd, and as you can see, this script is freaking enormous, and it has a lot of things which are very specific, very hard-coded, including, references to very specific nodes, which must be present in the scene for this to even load correctly. So I went on and started a player refactor. So I created a character scene, which, as you can see, is very tiny compared to the player scene. And the character scene can take a controller. What a character controller is, not control, character controller. A character controller is a class, actually it's a node, it can be a scene, that feeds the character inputs like move forward, move backward, shoot your gun, reload, aim left by X degrees, etc. So the basic character controller class will be a template, and on top of that there can be a character controller that basically takes player inputs, so registers actions from the input system of Godot, and basically forwards these inputs to the character. And this is what this does for now. So, for example, if there is a mouse movement, then there is a new event is created, and the mouse movement is translated to data inside of this event. And I've created a bunch of classes that define different data structures. For example, character controller communicates with the character by sending character controller event signals, and every character controller event signal has to contain a character control event. So a character control event is a package that contains a bunch of control changes. These can be, for example, button presses and releases, aim, relative changes. So if you move your mouse, this will go here, as in like you moved your mouse by 5 pixels. Okay. Left, etc. There's also absolute ones for resetting your playback and replay, for replay capture and playback. Basically, to replay a playback, to replay a replay, we need to know where we need to place the character and what is the aim. So we need to be able to store an initial state of the character so that we can replay the actions, and replaying the actions is implemented in the character controller. So if there's a playback function, replay function in here that responds to certain buttons. If you press replay capture button, it's gonna start capturing the replay. If it's replay playback, it's gonna replay that replay. In the physics process, it checks if it's replaying a replay, and then it's sending events in order. So basically what the character sees is nothing but a series of calls of events emitted by the character controller. The character has no idea where these events are coming from. They could be coming from random number generation or player inputs on the keyboard and mouse, or from playing back previous actions, or could be coming over the network, I don't know, or could be coming from an AI. So the idea for a character controller class is that this can be used to implement various AI controllers. Because this is a scene, the character controller is a scene, and it's instantiated with code at the head of the character. So the character controller can implement, some collision areas, raycasts, various things that it may need to like analyze the situation around itself, to orient itself in the world, etc. So here, character controller has a list of various character controls that it can identify. And this is just an array. And every single item is a character control that defines a character control type and an assigned associated input action. This is specific for, a player controller, which will be a class descending from this, but right now it's in here. In the base class, this would be missing these actions because the base class doesn't really know about player inputs like user inputs. But it's here for now because this is the base class. So I'm going to split this off into player character controller, or character controller player, or player character controller, whatever. Okay, so character controller is feeding events to the character by emitting, it's feeding data to the character by emitting character controller events using the character controller event data. So every time something happens, you move your mouse, it sends one of these, and they can contain any number of pressed keys or released keys, any change in aim, or can contain absolute aim or absolute location. I've also put in data for sending a message in chat. This is not used yet, but what is used is event order, which is index. That means all the events must have incrementing indexes. This is mostly for debugging right now, but it can be later used for checking validity of a captured replay, or filling in gaps if a server didn't get all the messages and it can see, oh, I missed some, and can request those, etc. And there's also frame, which is kind of like index, but index only increments when something changes. Frame increments whenever a physics tick occurs in the engine, which is 60 times per second. So this is necessary for the character controller to be able to replay captured actions with correct timing. How does this work? When I hit F6 in the character test scene, here is a character test scene where I have a character. The character has a character controller, and the character controller is, it's the default character controller. So if I hit F6 here, this scene will be loaded, and you can see I can move my mouse around. If I hit F3 in the background, now all my actions are being recorded, so I can look around. And then if I hit F4, these actions will be played back. I'm now not touching my keyboard or mouse or anything. We're watching a replay. Okay, the replay ended. You can see in the... Okay, if I made this a little bit smaller, let's replay the demo again. I'm hitting F4, playing back replay. You can see in the command line, in the debug output, it's the character is receiving exactly the same events that it received when I was actually performing this as a user. So the character scene doesn't know where the events are coming from, and it doesn't care. And we could also record some really short events and just replay them over and over and see, A really cool thing is that this will allow us to also heavily debug, because, we can pretty much record anything that happens in the game and then have the game perform all these actions for us again, and we can test, for example, if a bug occurs, and we can replay it as many times as we want to make sure that the bug is fixed. Or record players' actions and then be able to, animate a custom camera inside of the game and record a cool video from the gameplay. All right, so this is how it works for now. I am right now there is no movement, only mouse look implemented, but it's been a lot of work to figure out the data structure, and it's not perfectly clean up yet. There's, as you can see, there's a lot of commented out code that's going to be removed because I've been trying a lot of things, so this will be all cleaned up. But yeah, I think this needs to be filled in as well. I think the next thing I'm going to be working on is implementing player movement, because this I wanted to implement player movement and also replaying the player movement, but I've realized my data structures are not really ready for that. So I've done a whole bunch of work on restructuring my data containers and redefining my classes for stuff like character control, which holds like a single action, like it takes information about a single button you can press or release, and the button can be either, it can be either pressed or released. Like here, it can be enabled or disabled, and it also keeps track if it was changed or not, and it can be assigned an action that is easily evaluated. We can also get input change to pretty much just evaluate if the input module identifies that this action is currently being checked or something. I believe that if we actually hit some keys, okay, I don't know. Oh, these aren't played. All right, okay, yeah, these are not played, but we can do that if we just change the controller event to print the entire event. Yeah, I was testing binary encodings for efficient data storage, but that's not really necessary now. Okay, I'm gonna just print oh, okay, I know what I'm gonna do. Print and a good idea is to do var to string. So this way we can print the entire event. And I'm gonna maybe comment out these two. Oh, missing a parentheses. Okay, let's try again. F6. Now, I don't know why is it gray now. Oh, maybe I'm in the wrong scene. Yeah, I'm in a character controller scene. Okay, let's move to the character test scene and hit F6 again. Okay, and now you can see every time I do something, we have an event, which is an object of type character control event, and it contains an aim, vector2, and also index and frame. If I press a key, oh, interesting. It's the key presses are not listed here yet. Okay, so that's a missing feature. Basically, yeah, that's something I'll be working on next. But if this was working as intended and the control changes on this list, we would have objects listed defining when I pressed or released a key and telling us which key it was. And this information will be feeding character, so that character will be able to keep track of what's going on in its, like what's the internal state of the character's controls. Is the move forward pressed? Is the move backwards pressed? And whenever a change arrives, it's going to update its internal state and act accordingly. But because only changes arrive, this means that the player can receive an event, oh, move forward pressed, and it's going to change this to enabled, and it's going to like keep moving forward every frame until it receives another event that move forward is now disabled. Then it's going to update this to disabled and stop walking forward. This was much simpler in the huge monolithic player class, because we just had things like physics process, and here if inputs are true, we just process stuff. So the thing is, if input is action pressed, is move forward, this all will be pretty much reusable in character.gd. Only I need to change this to instead of if is action pressed, I need to do if controls, and here is our dictionary of something, say move forward enabled, and then we do this stuff. Yeah, I'm still figuring out the data structures, because like character, should I be using these? And then like I'll probably need to iterate over the binary controls, check their type, and act accordingly to the type. So like for control in binary controls, do match binary control dot control type to and every single case of these, and then write out what I need to do, what the character needs to do. It's either and change a vector of movement, or apply jump, or whatever. Yeah, so I'll be working on this. Thanks for watching. Let me record a short demo for you once again. Looking at blue, looking at red, looking at white, looking at green, doing crazy freaking moves. Like the frame rate drops really crazy, but I will end up looking at red. Let's play it back. Okay, now I'm not touching my mouse. The game is playing back. Looking blue, looking at red, looking at white, looking at green. Crazy moves ahead. Okay, the frame rate drops. We'll end up looking at red. Yep, we end up looking at red. Everything is perfect. End of replay. Stopping playback. There were 6,973 events recorded during only 968 frames. And as you can see, this is a bit problematic, because we can have more events than frames, and that kind of doesn't make sense. I mean, it does make sense, but it doesn't seem like it should be actually happening, but it is. When the when the frame rate of the game drops, or if we just move our mouse very fast, the mouse polling rate is higher than 60 frames per second. So the game is able to register more mouse movement data points than there are physics ticks. So an optimization that can be done is to aggregate all these events and just add these aim vectors together, which is pretty funny, because it also seems like it always increases one or another. Oh no, here it increases, here it moves both directions. So yeah, I should aggregate all these aim vectors as long as they belong to the same frame, like here, frame 923, and just condense these into a single event. The numbers will be larger, but there is going to be much less wasted data, because we don't need to send all the other stuff. This will increase the storage capacity and yeah, basically be much better. Okay, that's all for today. See you later.